I'm Professor Ian Eames, and I've taught you this year MEC 0024, Term 1. And what we're discussing today, very briefly, is MEC 0020, in particular the use of what we call LaTeX as a way of writing your thesis. It's not pronounced, it's pronounced latex, not latex. And actually it started off as tech and then became LaTeX. So when I was a student, we had a kind of stripped down version called tech and LaTeX. So let me just discuss the philosophy of LaTeX. So LaTeX is quite beneficial. It's used in all book preparation, but what it is it's a document preparation software. Now many of you will obviously use Word, and Word is great if you're using lots of different types of medium. Probably you can put videos in, graphs, all sorts of other things, multimedia. What's the challenge of using Word for a thesis? So this is good for general stuff, but it's very what we call heavy for technical work. And what I mean by that is that when you prepare a paper or a thesis, then usually what you have is a lot of figures which need to be referenced. You have a lot of equations, they need to be formatted and referenced. You have a lot of references which need to be formatted, and you have contents, nomenclature. Now one of the challenges of using Word is that it's sometimes quite problematic to put all of these labels together, particularly if you're preparing very, very long documents or there's lots of equations. And the other thing is Word is what we call a very heavy processing package. And what I mean is that if you have a 200-page thesis full of figures, full of text, you will have great difficulty sending this around to people, them opening them up, making those changes being updated automatically. So 200-page thesis, you could be talking 20 to 100 megabytes, and as the size grows, your ability to move it around, get people to look at it, is greatly reduced. Now there's an alternative to this called LaTeX. So LaTeX is not the same as Word. It basically uses macros. It's text driven, and it has that flexibility that you can put together your equations, your figures, your references and contents in a very straightforward way. And not only that, you can change the format of the document you're writing instantaneously by just changing a single element in it. And it is very light. 200-page thesis, you're probably talking about maybe 200k at most for the text, and whatever the figures are, it will bring them in on the fly. So figures on the fly. Now you because of my kind of points about equations and references and contents, you'll have a belief that maybe this is for kind of mathematical pieces of work, but it isn't. You'll see people who do their research in English and history and economics and geography. Almost everybody uses LaTeX. So let's just get the general principles of LaTeX. LaTeX is a script-driven language. It sounds complicated, but it's not. But it's quite the syntax is quite explicit. So script-driven. And so it has three parts to it. So writing your thesis, then there's what was called a processor, and then a viewer. So when you write your thesis, it's usually got a word like on the main.text, but as it generates, as you process it, it goes through the syntax, so it's explicit, and if the syntax isn't correct, you've got unbalanced brackets, all sorts of things, it will fail. And so it's a good way of checking that your writing and how it's all put together is all okay. So you write your thesis with a main.tech, and you'll draw into there what we call style files, SDY, and then class files, which kind of tell, and it'll produce an output. So style files are basically how you might want to make your paragraphs look, not your paragraphs, tables look, and class file would be, you know, the overall description of the type of thing you're looking at. So for instance, we publish in JFM, there's a JFM class file, there'll be one for physics of fluids. Every journal and every publisher will have their class file, and you can pick them up, and they're all pretty straightforward. But the main one you normally deal with is the main.tech. Sometimes for neatness, and so that you can see different parts of your document, you may want to break your main tech file into having inputs for different chapters, chapter 1. So if you're managing hundreds of figures for your thesis, for instance, not necessarily the case here, but you would generally have to provide some kind of structure to how you store that. When you output or process it, so I should put that over here, it's going to produce log files, and they're going to give you a list of the contents to generate your contents pages and your bibliography. And generally you would need to process this or run it more than once. So normally it would be twice for the bibliography, 3 times for the contents page. So automatically most software do it a couple of times, but the log files generate references of where the very specific pages are and the labels, and then this is fed back into here when you latex. So this is called latexing. Now this is exactly like a computer program. You would have your code, your processor, and your output, however you view your output. So the syntax is very much code driven. The viewer, in the old past, you'd have a what we call a DVI file or PDF, and so most people now use have a PDF viewer. In the old days, you'd get a DVI, and then you would convert the DVI to a PDF. PDF. Now at UCL, like at many institutions, we all now use this overleaf, and you all have an account as a student here. And overleaf is a cloud-based LaTeX package. It's quite a new package. I think it's only been about 4 years, but it's absolutely brilliant, and I'm going to show you how to use it. The benefits for you as a student is that it keeps your work safe, and the other benefit is that you can share your file with the supervisor. Now, it's very difficult sometimes for a supervisor to necessarily read a very long Word document and add comments and then track changes, but this has this facility. Because it's very light, it is quite good. I would say it's a brilliant capability of that. And so what I'm describing to you is basically what we use on a daily basis when we're writing our research papers. So I'm just going to stop there, and we're going to go across to overleaf. So what we're going to do is going to start off log in with the SSO. I'm going to log in directly. This brings me to my list of activities. So just give you an example of one that I'm kind of working on at the moment. So this is a piece of work that I'm working with Professor Floor. So I've got a collaborator. This is a revision. I don't think he's accepted a change. And the reviewing is tracking is on. So tracking on, everyone makes those changes and they'll can see those differences. And so what it allows you to do, so if you look on the right hand side, that's what your target thing looks like. On the left hand side is the set of macros, and you kind of read this a bit like code. You want document class to be in JFM. These are a set of macros and packages that are hoovered in automatically. You want a title to be this, penetration. There's a long title, short title, the authors are this, affiliation, and then basically you basically start off with begin the document, make the title, begin the abstract. So here's the abstract here, end the abstract. At the end of the abstract there's keywords, and so you see everything begins has a begin and an end. It's very much a bit like code. You start a series of declarations and you end it. Some different things are different, like sections. You just start the section introduction, and how you hoover in the references is really through a series of calls to the bibliography. So the bibliography is actually a list of files that kind of refer to published pieces of work, and you can pick these up on Google. Well, I'll show you examples in a minute. But the gist of it is that, or the simplicity of this is that if you go to something, say mathematical, like here, definition of double click to get to it, definition of impulse, then impulse is defined as the cross product of position and vorticity. So weighted integral of the moment of vorticity, and this is bold omega. So we see how it's written here, bold omega, and you notice the mathematics is between the dollar signs. So dollar signs, between the dollar signs we put the maths. If the equations sit on a line, we start off with begin equation, end equation, and the right hand side, you might not be able to see it, but I would read this bold I equals 1 over 2 x bold x cross or times bold omega. And that's how we work our way kind of through this. The curl operation here is basically bold nabla, so bold nabla, and as you probably expect, all of the Greek symbols, alpha is written / alpha, beta's / beta. You can look up all the mathematical symbols. You notice with some of these things I've got a, if I refer to them a few times, then I give them a label. And so one of the benefits of this is that you can label the equations. So this is equation, where are we going here? Where is it linked in? IEV. Yeah, so if we go over here, let's go linking the equation directly. So if we go over here, it has this term here. We can use this simple model 2.9. We can use this simple model reference equation source. So it's a reference equation source, a label equation. So in the equation, it's described as a label. That same wording is referred to as a reference when you want to refer to it later. Let's go back to the beginning and let's start off our thesis. So we go to templates and we search MEC 0020. So what will come up is a something we can open as a template. This is going to be revised slightly, but the essence is there. How this is set up, this is what we call a vanilla version of code, because there's very little going on here. It's got all these references that I need to cut out, but essentially this is what we call a vanilla version. We've got 3 files here. We've got on the top left, we've got thesis mec0020.tech. That's the name of your file, where it contains all of the commands and information that creates the document on the right hand side. It's got a style file. I'm not sure why I've put style, which style file I've got in here. Time T. Let me have a search through if I actually use this. Oh, I use it for something. Mate, what do I use it for? I was going through this. I've got a style package nomenclature, which is quite useful. This has been asked to put in this. So how we read this is this. It says create a document that's 11.2 column and call it an article, which is a type of file. You can have, instead of an article, a letter, a book, a paper, all sorts of other things. This changes the geometry. So the Word version wanted a kind of wide page, so this uses a package geometry that just basically tells it's A4 wide how big the margins are. You can play with these. The additional packages it loads in are very specific, so it wanted, if we want to load in graphics, we've got to upload use package graphics, so it sucks that in. Use package nomenclature, there was a request to put nomenclature in here. And so the way it was set up, you wanted a times package, so put times in. And as you can probably read through it, you've got this begin statement, begin document, which must be married up with the end document. If this is not married up, it won't work. Now, how do you go from the left-hand side to the right-hand side? Well, you press that button, compile. And what it's doing is there is a processor that on the fly goes through this and transforms what is on the left-hand side to the right-hand side. So let's just go through. So you've got a title and an author and a date. And so you can change that date. So I'm going to change it today, which is March. You can do it automatically, but March 11th, 2024. I'm just going to compile that again, and what you'll see is this text there has changed. Yeah? Now, for some documents you don't label the first page. Here we've changed that, so we label the first page. We've got the ability to share, so it's a possibility of sharing with your supervisor because they can have a look at it. You can get them so they can only read it. Reviewing collaborative is a really good thing. I always put that on if I'm working with people, so I know who's done what. There are a couple of ways you can visualize this. You can visualize this either with this thing at the bottom, the code editor, because I'm a bit old school and I've done this for quite a few years. I read the code, but sometimes people look the more visual element, which is a more bit closer to looking a bit like Word. You can go through and insert the maths if you're not familiar what the math symbols are like. And there's probably other things, symbol page, miscellaneous operations. So this will be sigma, sum. Oh. So you can, anyway, so first page, label the first page, which basically put a 1 on it, make the title. These are all pretty standard syntax, so usually with most of these things copy and paste. Begin the abstract, end the abstract, so you've got a couple of explicit constraint on how many words are there. Now you can create a nomenclature as you go through. So as you go through your file, for instance, we're starting with section 1 introduction, we use the following equation. I give this equals MC squared label equation double colon equation. You put any word you like there, and let me refer back to this. So there are a couple of ways of dealing with nomenclature. I can either explicitly say it in the text, or I can put this line here in nomenclature C, speed of light. Now the benefit of this second way that we've been advised where you've been advised to put is that it saves you a bit of space, and so when you compile through, it creates a list of the nomenclature, saves it, and so when you compile it again, it will produce that list exactly where you say print nomenclature. Now you don't see the compilation multiple times, and so you'll just see this immediately appear here. So let me just add something here. So we use a following equation to estimate the energy produced during nuclear reaction. The equation, now maybe I want to refer to the equation. Now how I do that is I put a reference equation, and now it's, because of it's a very good way of doing it, it's got an automatic list that will allow you to tab through those kind of references. well, I don't know which paper Einstein derived it, but let me have a look. So let me just compile that first to show you that that link to that equation is that equation 1. Yeah, and now I don't know which paper Einstein used, so let me just go to Word, Google. Now which one it is, so let's have a see. I'm not sure which one it is, but let's just say general relativity. On the theory of general relativity. Let's have a see. So what I would like is the reference to this, so let me just have a see. Someone will have it. Go here. BibTeX reference for so this is it. So you can search it. It'll give it. So I've got this BibTeX is the way I refer to. It's referred to as this. So if I go back to overleaf, I've got this copied. Go back here and I go back to the references. I'm just going to put that at the end. And so, and now to refer to that, I just copy the bit at the top, and I say derived by Einstein site Einstein. So let me compile that. So remember what I did is I took the BibTeX reference from searching on Google. I got the reference, I pasted it into the manuscript's bib, and automatically reversed it. The only thing I would say here is I wouldn't be too happy about, it doesn't say the page numbers and the journal reference is missing. So I would in my particular case, I would probably be very clear about or search up which journal is actually publishing, because at the moment that Foundation of General Theory of Relativity 1916 doesn't include the reference to the journal, and so that's not such a good bib reference, but I would do a bit of searching to kind of clarify that bit. So let's just go through. So we're at the equation 1 was derived by Einstein's foundation. And so if you click the 1, it goes to reference, and so derived by goes to Einstein. If you click this, it should just go to, what is it? Yeah. Okay, so nomenclature is given here. So you've got your lit review, and as you see, the lit review is a new section. So we do section literature review, section theory and calculation. As we see here, this is a typical equation. So begin equation, end equation is how you start and stop. I would format them generally like sentences. F of x equals a underscore naught plus sum. So we do sum, n equals 1 to infinity, left bracket a underscore n backslash cos n pi x over l plus bn sine n pi x over l right bracket. So after a while you basically see the equivalence between the left hand side and right hand side. Tables are straightforward. I think the challenge here is that you've got a double column, so there is might have to play a little bit with the spacing in order that you don't overgo over. So you have a little bit of so it doesn't merge with the right hand side. There are ways to do it. I can look these up and give you some advice on that. That's not a problem. Let's just overcome the first problem of you having a workable file. Now figures are a bit interesting, so not generally what we do is we do begin figure, end figure, caption, in this particular case UCL logo, and you include the package, include graphics, and this declaration width equals 0.45, text width tells me that I want this to be about 1 column width. If I made this bigger, let's say 0.95, and compile, then what it'll do, the figure will go across the 2 columns and you'll end up with problems. There are ways to kind of sort these things out, but I'm not going to cover that now. Recompile. Try and make sure your captions say something meaningful. Don't forget to label them and refer to them into the body of the text. So the way I put the figures is I would put them into a figure directory. If I had a long paper or a long thesis, then I would have a chapter for. I would have a folder for each figure. To upload the figures, it's pretty simple. You just basically copy and paste them in there, and they'll upload. You have to declare all your use of AI tools, so please look at the references. Now the format that they've given you, there is a strong emphasis for your thesis on having technical component and also the conclusion, so don't forget to write something about there. If there are any issues, and this is kind of work in progress, then just feel free to contact me and we'll make those changes. So happy Latexing.